I'm very excited for the next session. Okay, so I just want to say that there was a time not too long ago when most people thought air travel could never be decarbonized. And it was common thought. This is the furthest thing from the truth. And the next panel is going to talk about that deep decarbonization, not only for aviation, but also airports, covering everything from alternative fuels, sustainable aviation fuels, all the way to zero carbon, clean and renewably hydrogen powered flight. So with that, I would love to welcome our panelists to the stage. Come on up, guys. We like to try to run things on time. And while folks are joining the stage, I want to provide an introduction for our moderator, who is Mike Petahoff. He's the Associate Principal of for the Hydrogen and Sustainable Fuels for the Americas. He's the lead at Arup. I've known Mike for a very long time. And so I know from firsthand experience, he has really a lot of experience as a global clean energy leader focused on green hydrogen and renewable energy transition broadly. At Arup, Mike is a member of the Global Hydrogen Senior Leadership Team, and he works on projects focusing on the effective utilization of hydrogen to meet environmental needs, including ports and airports and grid reliability, all of the favorite topics of this conference today. Prior to Arup, Mike has had a really diverse career working both in government and industry, including having served at the CEC. He led the CEC's hydrogen roadmap for a decarbonized California. He also worked as Apple Computer's global energy team leader. Apple is famous for their renewable energy and Chevron Energy Solutions, which is, I think, when we first met. So you're in for a treat. Please join me in welcoming Mike and our amazing panelists to the stage.
Thank you, Janice, for that kind introduction. Let me say, as I introduce the panel, I am really excited about what we're going to share with you today. The process just of getting this group together has been really edifying, just to see what industry leaders in aviation and hydrogen are doing. And it really gives me, to Janice's comment, that this was something that we thought was sort of not very plausible a few years ago, that this is really doable and in the very near future. So let me just introduce our panelists, and then we'll jump into some questions and then take some audience questions as well. There's detailed bios in the package, which I encourage you to read, which are very rich. But we have Todd Solomon, who's from ZeroAvia, acting as their government affairs and public policy strategist. We have Jack Brower. This is the order we'll speak in. Jack Brower, who's a professor of mechanical and aerospace engineering at UC Irvine. I don't know, in my mind, come to be known as Mr. Hydrogen, Dr. Hydrogen at UC Irvine, and a key player as the industry has developed over time. We have Crystal Lee, who's the Deputy Executive Director of Energy, Sustainability, and Environmental Development Services at LAWA, which guides LAX and other aviation resources. And Aaron Cook, who is at SFO Airport, Sustainability and Resilience Director, and also co-chaired the Aviation Hydrogen Working Group for ARCHES. And we have Sarah Chow also, who works for American Airlines as the manager for decarbonization. So we'll get the airline perspective. So let me just give a few comments of introduction to frame this thing. So let me say, we start with a conundrum. Hopefully, Katya can bring that up. A conundrum we often call the chicken and the egg. In hydrogen in general, we talk about the need of having producers who are looking for creditworthy off-takers and off-takers who are looking, where are those people that can give me a dependable supply of hydrogen? In the aviation world, it takes it a little bit broader. We really have multi-parties of hydrogen suppliers. We also have the airports, the aircraft manufacturers, and the airlines. And all of them need to be working together. And it's really a matter of building capability and trust. The airports, let's say that the aircraft manufacturers can't really make the airplanes unless the infrastructure is there at the airports to support them. The airlines aren't going to buy sustainable fuel unless it's cost effective to do so, and there are infrastructure and airplanes available. And the suppliers are sort of maybe on the sidelines waiting for this to happen, but also needing off takers. So we really have all of these things working together to build capability and trust. But what we want to talk about today is the benefits of combustion-free flight. So in the above part, we'll stay on that slide for a second. So we're going to talk about safety, capability, and a lot of different things like that. But the benefits of combustion-free flight are really a couple thoughts. One is we're eliminating not just CO2, but also other particulates of concern. And we'll really focus on those. Other residuals of combustion like particulates, NOx, SOx, and those sort of things. And we're going to take this in steps. What aircraft are available, we'll see what those timelines look like, both for aircraft and ground support equipment, but also that there's something called sustainable aviation fuel. Some people view that as a competitor to hydrogen, but in fact, sustainable aviation fuel can be made with hydrogen as a component and is available right now. So that's an easy, low infrastructure modification step, but still requires combustion. And then hydrogen takes us to a next step of being able to have flight that doesn't involve combustion. So we'll explore that in a little bit. So one thing we'll talk about today is hubs and corridors. And so this is kind of a new field, so we're defining the terminology. But when I talk about a hub, we could have LAX or SFO operating as a point of aggregation, as a place where hydrogen is consumed by aircraft or other uses. And that point of consolidation can be a hub. There's a virtuous cycle of more quantity lowers the cost, lowering the cost increases the quantity, and eventually we beat the status quo price, and then you have sort of an avalanche effect. So we've seen that happen in wind, we've seen it happen in solar, and that point of aggregation as a hub for an airport is an important aspect in furthering that. So we have aircraft as early as 2027 that can support operation as regional hubs. So if we're going to be doing that, we need to be planning like now to be doing these things. The next step, just a little bit up the road, and those aircraft are maybe 9 passengers, a couple hundred nautical miles. The next step is really larger planes up to 80 seats with an 800 nautical mile range. Here we enable what we're calling a green flight corridor. And in fact, we borrow this term from the maritime industry where there are green shipping corridors. There are actually 62 green shipping corridors in development right now, but we could connect SFO to LAX in a green flight corridor with fueling capabilities on either end. And it's one of the most heavily traveled routes in the US and in fact in the world. So that would be a pretty important development. We have SFO and LAX here. We actually have a representative from Oakland Airport, so Oakland could play a role in this as well. We have Austin out in the audience there too. So certainly the idea of a corridor where we can go on either end is in the very near future. And then I would also share that ground support equipment is a way that many airports are taking a step even now. Ground support equipment is available. This is a pushback tug in use by the Air Force in Hawaii, but many airports in Europe are beginning to adopt ground support equipment fueled with hydrogen. Like the maritime applications, what's preferable often is it's faster to fuel these vehicles than it is to charge an electric vehicle. So if you're going with zero carbon, hydrogen provides an advantage available now to become accustomed to the safety issues, the logistics of using hydrogen. So with that, let me jump into some questions. Let me start with Todd. Todd, can you give us some insight about sort of the type of aircraft, the availability and the timelines, and a little bit more about this notion of carbon-free or combustion-free flight? Can you tell us a little bit about that? And I'm actually going to shift over. I have a foot injury, so I'm going to shift over and jump over this rail to sit with the panelist on the stage here.
Cool. Well, I think the most important thing to talk about are the benefits of hydrogen electric flight. So Zero Avia makes hydrogen fuel cell powertrains for aircraft. So we have a hydrogen fuel cell, a tank of hydrogen on board the aircraft, create electricity, run it through our inverter into a motor, and that motor spins either a propeller or a jet turbofan. The benefits are, in addition to no carbon, There's also no emissions whatsoever except for water vapor. And we can control the temperature at which the water vapor is emitted so that it's not contrail forming. And the reason that becomes important is because there are studies out there and there's a body of people working on contrails that indicate that contrail formation might be 2 times the impact of carbon on climate impact. So it's significant. Also, because it's truly zero emission, if you are a legislator or an airport operator, you don't have to hear about air quality issues in the community. This is a way of cleaning up asthma and other medical complications associated with aviation, particularly at takeoff and landing, where those emissions are more extreme. Similarly, because you're not doing combustion, you have a reduced noise element, which is also conducive to better outcomes in airport adjacent communities. There will be propeller noise in our first couple of iterations as we're going to use propeller turboprop aircraft. Key benefit is improved cost. So I think we've learned since November that nothing is going to happen climate-wise in this country for a while unless it also meets an economic threshold. So we are looking at 25 to 40% reductions in operating cost. So that's from fuel cost and maintenance costs. So there's a significant economic advantage. One of the benefits of that advantage is that there are routes that are currently not economically viable in the country to smaller communities. And so the thought is that improved economics will lead to better service to underserved communities. So,
And if I may, we're trying to get through each speaker within like 3, 4 minutes so we can leave time for questions.
All right. Can we roll the next one? All right, so this is where we've been. Basically, just show you that right now we're in certification with the FAA on our electric propulsion system. We're in certification with the CAA in the UK on our complete powertrain. So this is a thing that's happening now. It's right. So we're looking at a couple of years until the full powertrain is certified. We expect the electric propulsion system to be certified in the US by the end of next year. Next one, please. And this is a bit of a roadmap. So as I said, the first iterations are turboprop, but you can see that in 2030, we're looking at regional jets. So that's the kind of flight you might take to a hub if you don't live in a hub neighborhood. And then eventually we're looking at the holy grail of this thing, which would be narrow body, single aisle jets that you're all used to flying. So. All right, that's it.
Thank you, Todd. It's amazing to see how much in the near future these aircraft types are coming. Let's go to Jack Brower. Jack, I understand you've done some work on the hydrogen supply, specifically focused on LAX as a case study. Be interesting to see what your findings are, what the cost structures look like, and how feasible this is to get the supply. And I wonder if you could comment on that virtuous cycle as well.
Sure. So I'm here to present a paper that we just recently published. You can see my co-authors here on the economic and technological feasibility of using hydrogen to decarbonize flight at LAX. And we've been building these physical models of all the infrastructure, the tanks, the conversion devices like the fuel cells and the combustion systems, including all the physics, chemistry, and electrochemistry for several years now. And these have included looking at turbofan engines, looking at PEM fuel cells, looking at solid oxide fuel cells, and next, also applying these to various aircraft. Because there's a lot of different aircraft that we can retrofit and or build from scratch that use these hydrogen propulsion systems. So you can see here that we're looking at futuristic type planes like these blended wing body aircraft, but also retrofitting or purpose building these tube and wing aircraft and considering the dynamics of their actual flight going from, for example, here, SFO to Shanghai. And yes, assessing all the emissions that are associated with these. So you can see dramatic reductions of all the hydrogen options, not only for the carbon emissions that you can see on your right, but also the criteria pollutant emissions. At LAX, we looked at 4 different scenarios for taking electrolytic hydrogen produced all from renewable electricity through electrolyzers and in various ways delivering that hydrogen to aircraft. So we looked at the solar available near LAX and the wind available near LAX. And what you can see is that there's sufficient wind power available offshore and sufficient solar power in the desert. With pipelines and or truck delivery, we showed that these dynamics of the wind and solar could be accommodated. We could economically determine how much it would cost to actually implement this using current technology for 2030 and futuristic technology for 2050. And this is what you end up with. By 2030, if you build these renewable electrolysis delivered liquid hydrogen to aircraft, you can get it for about $7. That's pretty amazing, right? All infrastructure together. By 2050, you can get to numbers that are in the order of $4 per liquid kilogram delivered to the aircraft. It's pretty amazing. Technological and economic feasibility.
Thank you, Jack. It's a picture of the future. Next, let's go to our airport folks. We'll start with Crystal. Crystal, I wonder if you can help us understand the challenges that are faced by a sustainability manager at an airport and how these technologies could help, both for carbon reduction and also the reduction of other criteria pollutants, which might be of concern to the local stakeholders that live around the airport.
Sure. Thanks, Mike. Hi, I'm Crystal. We do have quite a very complex situation at LA because we're almost a city within a city. We absolutely are a city within a city. I have a lot of fun facts posted on here, but I'll just read off a couple. We have over 75 million passengers that come in annually, which, I mean, I think looking at some of the other folks that were presenting, they are facing these challenges and looking at the industry technology, but our impact is so huge that those 75 million passengers equate to about 1.6 billion gallons of fuel a year. That's what we calculated as of last year of 2024. And that does not include our Van Nuys piece. So LAWA is Los Angeles World Airports. It's LAX, Van Nuys, which is the largest general aviation airport in the United States. LAX is the 5th largest in the nation. And then we also oversee Palmdale, which is smaller. We don't really operate that, but it does have some environmental impacts as well. So those are things that we pay attention to, but looking at the cross culture and the cross sections of what we have to analyze as an airport, you know, we prioritize safety, we prioritize the passenger experience. We're looking at the complexity of actually the logistics, infrastructure, and operations happening day to day, and then building in how do we see a profit? You know, how is this a business? So taking all those things into consideration and trying to embed sustainability as an overlay into that is kind of what I've been trying to do as far as bring culture and align all of our CIP projects, capital improvement projects, to our sustainability action plans. So what I've been doing, I've only had sustainability, environmental, and energy for about 6 months or so. So I'm doing a huge refresh. We haven't touched our sustainability action plan since 2019. California has 5 major goals to go zero for emissions, 100% recycled water. We are doing zero waste. So we have a lot of initiatives that are in the works across the board. But what I found was we didn't have a really good roadmap. And what we're doing is revitalizing what that's going to look like, how we're going to get there, and identifying really specific targets. The approach we had previously was just tackle the low-hanging fruit because of the complexities that are, you know, we get in our own way type of conversation. But now I think we're going to try and have what I learned from Aaron, this term of what has the highest impact. What can we do today? So some of these things, knowing that we spend $1.6 billion of fuel, if we can now tackle that with options like SAF and hydrogen, that would be a massive impact considering what we what we spend annually. I would also say that right now we are currently looking at 7% at LAX of SAF compared to others. I don't know in the impressions of the audience if that is a lot to you. To me, it was not very much because it was so far from 100, right? So maybe that's an opportunity for hydrogen to play a role in that gap as we start seeing technology develop. And thank you, Jack, for doing all the legwork. I'm going to bring that in and we'll figure that all out. But I think this is the opportunity now to try and figure out how we can roadmap from the technology to our existing infrastructure and leverage our existing assets. We also have an existing CUP, the central utility plant. It's 2.6 megawatts. It's not a lot, but it's a really good opportunity to provide some kind of leverage to bring hydrogen or some line to replace what's now just gas fuel to that CUP. So if we bring it to campus on site, we can then have an opportunity to provide gas to potential airlines and other opportunity usage. These are just some decarb efforts that we're working on that we had started in the last couple of years. We're definitely working on our fleet, electrifying that, both our trucks and buses, and working on heavy truck traffic and our heavy duty maintenance vehicles and some other opportunities using electricity. And we just got a new massive switchgear from DWP. Thank you for that. But it's not going to bring us all the way there. So I think we definitely have to take hydrogen very seriously.
Thank you very much, Crystal. Let's go to our next airport manager, Erin Cook. Erin has a dual role. She's Sustainability and Resilience Director at SFO. She also co-chaired the Arches Aviation Working Group. So I'd like to hear your perspective on what opportunities these kind of technologies offer for you, both for carbon reduction and again for the constituents of concern to local stakeholders, and any perspective you have from the Arches Working Group as well.
Great. Thanks, Mike. And thank you so much for this event. It's been really helpful and insightful for an airport that's looking at what these energy transitions mean and how we can really prepare our infrastructure in order to enable it. So what I'll talk about really briefly, it's always helpful just to have a sense of where I'm coming from and the organization that I represent, as well as the geography and the boundaries. So again, similar to Crystal, I won't talk you through this at length, but just to note that similar to Crystal, our portfolio of land is about 5,000 acres. 2,500 are already underwater. We have 7 miles of shoreline, and SFO takes its climate vision and mission incredibly seriously because of that shoreline. We have a multi-billion-dollar shoreline protection program coming because the clock is not just ticking on climate change. The alarm is sounding. We can't keep hitting the sleep button. It's really time to go. And that is foundational to all of the work that we're doing. So we have tons of buildings, 103 different buildings, about 22 million square feet of space. We're activating an $11.3 billion capital program. That means that we're making ready our campus for a future that is climate uncertain and will be here for the next 50 years. So as we're thinking about infrastructure investment, we really need to understand and get ready for the future that will require a lot of different implementation and adaptation of the infrastructure and the systems that we're working to enable. So on the previous slide that we don't have to go back to, just I'm hoping the slides will be shared. We have done a little bit of math around what our conversion to hydrogen technologies will look like. This for us is coming out of a hydrogen study, an energy transition study we're working on with WSP. They helped lead the work for SFO in SAF previously, and a lot of questions we were getting is sustainable aviation fuel is here, it's dropping, it's ready to go. What's coming next for SFO, especially as we're working on an implementation of our infrastructure modernization program. That for us is everything from putting in a utilidor that allows for mutual maximum flexibility so we can really plug and play the lifelines that are serving our campus, which here today are electricity, renewable diesel, gas, and need to be able to pop in and play and make ready for hydrogen. So all to say, we are looking into the hydrogen needs and demands for the airport. And we're doing that because our airport is really on a mission to take bold climate action as set in our climate action plan and the new airport mission statement, which is really not just being an airport that's targeting people and profit, but really focusing on planetary sustainability and resilience. So that is what's shown here, as well as our strategic plan objectives. They really match and actually try to pace set and go beyond what our city and our state have done. So they set goals at, 0 by 2045. As I mentioned with the clock, we don't think that's fast enough. So our airport is really targeting zero energy, zero carbon, zero waste, zero water by 2030. And we have strategic goals and plans as well as capital projects to enable it. So shown on the next slide are really just what are those plans? What do they look like? Oh, you cut a slide out. Nicely done. It's not shown in the slide because I think I got truncated, reasonably so, but on our airport's website, it's really a playbook for any airport, any large campus, whether a university or a college, or a corporate campus, to say, if you want to go net zero energy and you have lots of makes and models of buildings, this is how you do it. In addition to that, we realize that we have to broaden our reach and we can't do this independently. So SFO has been really working as part of multiple working groups. We lead our own SAF working group. We were the first airport to lift one up in 2018, but we are taking that model and road showing it with our industry association. So the Airport Council International, the International Civil Aviation Organization, a UN body. There's lots of different industry groups. What we've worked to do is say, here's what we've learned from trying to build a perspective out for our campus, and here's how we want to embed that into the work that you're doing. And so what's shown on this is that we're not starting from zero. We already have really great momentum, drive, and vision set for how we're going to integrate alternative energies, including hydrogen. Every single one of these is an aviation hydrogen white paper. What we've done with a level of specificity is built that out through arches for California to show what we can do today and what we can model in the future for ground equipment, for our buildings, and then all the way up through the types of airline and aircraft transitions that we need. So the aviation white paper is what Mike mentioned. And then on the last slide is just really, maybe you deleted that one too. Again, wink, wink. Hopefully they'll share all of my slides, but it basically gave a snapshot or a forecast from our white paper on what we think the energy demands are going to need to be, projecting hydrogen as a future drop-in replacement for the sustainable aviation fuel that we have today. Noting, however, that those types of energies do need to be ready to serve our current aeronautical and aviation related demands. And we're still not doing enough as a regulator and as a legislator. We're still playing catch up, and there needs to be a lot more shape shifting incentives and a much more compelling regulatory environment in order to enable SAF today and hydrogen in the future. So I'm hoping the folks in the room can help us do that. Thanks. You didn't delete it. Good job.
And thank you. So now we've heard from the aircraft supply side, the hydrogen supply side, a couple of different airports, but another important player in this ecosystem are the airlines, whether it be American, Alaska, Delta. And so we have Sarah today to give the perspective of the airlines. We'd like to hear your perspective about SAF and hydrogen both, the logistics, what you're seeing in terms of purchasing, and any obstacles that we might be able to overcome to make this more of an economic driver in California, and whatever else you think is relevant.
Awesome. Thank you. Thank you for having me. I missed the memo on slides, so no slides. I want to start with a little bit of a level set on aviation. I imagine folks in the room are familiar that it's a high emitting, hard to abate sector. A few other things that may or may not be top of mind that I wanted to touch on. Safety always comes first for an airline, as it should. This leads to very long and expensive testing and certification processes. And as an industry, I would say makes us quite risk averse. We're not an industry that is prone to wanting to take a lot of risks due to the safety impacts. We're also highly competitive in the industry, very low profit margins. We have high exposure to jet fuel volatility in terms of the cost of jet fuel, high exposure to economic downturns. I could go on this list, unionized labor, but point to say there's kind of a funny Richard Branson quote, if you want to be a millionaire, start with $1 billion and start an airline. So put that in contrast with in 2024, the World Economic Forum estimated $5 trillion with a T dollars to get aviation to net zero. In contrast with just shipping as another hard to abate sector, they estimated 2.6 trillion, so almost double. So that's kind of just the level set of aviation. In the prep calls, I'm a bit of maybe the Debbie Downer on this panel for how difficult this will be. In speaking a little bit about using hydrogen in terms of alternative propulsion before I get into SAF, again, we all know this compared to the drop-in fuel of SAF requires a complete rehaul of airport infrastructure, of planes, of fueling infrastructure. And that's kind of the chicken or the egg problem. Do you start with the planes or the infrastructure? Airbus recently announced that they were kind of taking a pause on development of their hydrogen aircraft because the infrastructure wasn't there. And kind of something else to keep in mind, right, is that airlines have very long fleet renewal cycles. And so when we bring aircraft into service, it flies for upwards of 20 to 30 years. So I did a quick search. American has 413 aircraft in our order book for the next about 5 years. Delta 285, United 680, Southwest 411. These will be aircraft that are flying in the 2030s, the 2040s, the 2050s that are not hydrogen. And so that's not to say that, we shouldn't be making advances in hydrogen, because of course we should. It requires a really long runway, forgive the pun. And so we need to be starting on all the building blocks for that and getting there. Erin's slide, if you caught just now, estimated SAF at, I think it said 75 to 91% of the greenhouse gas emissions reductions needed for aviation. I've seen numbers that's a little high. I've seen a lot. It's never lower than 60% for SAF. So that tells you how important SAF is as a drop-in fuel, as something that can fly on all of those many hundreds of planes that I just said. But that's not to say that it's not without its own challenges, right? So Crystal and I were chatting yesterday. She thought 7% was very low. The industry goal is 10% by 2030. And I will say we are significantly off track of that goal. Last year's global SAF production was 0.3% of global SAF production. We're just talking, this is right, like the biomass based first generation, second generation, and then where hydrogen really comes into play is third generation synthetic PTL e-fuels, all the same thing. And to give put that a little bit into perspective, recently the EU put a webinar on PTL. We expect a lot more production of PTL to come online to meet these mandates. And it estimated that with very low cost renewable electricity, that cost would be just for the electricity for the hydrogen would be about $4 a gallon. And jet fuel is about a little over $2 a gallon. Our fuel people negotiate fuel down to the third, fourth decimal point. So a 1 cent increase in fuel cost is $40 million to American Airlines in 2024. So that's just, again, I'm being a little bit of the maybe the cynic in the room, but there is still encouraging developments on the front. Last week, I was in West Texas at the launch event for Infinium, which is the world's first publicly announced PTL SAF plant to reach FID, and they expect to begin COD commercial operations in 2027. So again, like I said, with the mandates coming online, a lot more SAF production is expected to occur in these next 5-10 years, but we are a long way off.
Thank you, Sarah. I think we have a diversity of perspectives, and this is really helpful to understand the opportunities, but also the challenges that we faced. We did get some good questions from the audience, and thank you, panelists, for a lot of information, but managing time. We've got some good time for questions, so we'll go through that. So let me start with a question first for Jack and then for Todd. So Jack, you gave us some idea of the pricing, which looks favorable, but your study was electrolytic and hydrogen from solar and wind. If it were waste to hydrogen, do you think that would make a difference, and what difference would that make? And then the question to Todd, you mentioned about cost effectiveness. Do you think you can reach parity with SAF and with Jet A? But let's start with the first question for Jack as first.
Yeah, the study that we conducted and just published did not consider biogenic pathways. But Dr. Jeff Reed, who's in the audience here, led a study at UCI funded by the California Energy Commission, in which he was looking at various means of producing renewable hydrogen in the state of California. And it turns out that at the appropriate scale of production, biogenic means end up being cheaper, especially early on. And as a result, biogenic might be up to half of the renewable hydrogen that we might see in the near future. So I think biogenic means of making hydrogen are very important to the state. They also will be important forever, because we always have waste streams that we must manage, and making something that's valuable like an aircraft fuel would be appropriate for these waste streams.
Okay, and one final question for Jack that just came in. You mentioned a pipeline and delivering liquid hydrogen. Are you thinking the pipeline would carry liquid hydrogen, or would it carry gaseous hydrogen and be liquefied at the end site?
It absolutely has to carry liquid hydrogen, and we only considered those pipelines in the later years, not in the early years. But it has to be able to deliver the fuel that the aircraft uses to the actual aircraft. And right now at LAX, for example, there are pipelines that are delivering these to the aircraft, right? You don't always have a truck. You have trucks going to some aircraft. But so this is the kind of thing that has to be done for hydrogen too. And that's going to take a lot of years. That's why we said 2050 for that case.
Thank you. And Todd, I think.
Just to add, we can't have hydrogen direct to wing, just that would slow down all aeronautical activity. So just to emphasize that point, I think it's a really important one that we need to figure out how to get it at scale, similar to the other hydrogen systems that are feeding the airports.
The fueling logistics are certainly something to be thought through. Yeah. Yeah. And Todd, I think you mentioned the cost effectiveness. Sarah has highlighted the sensitivity the airlines have to even a 1 cent increase. So what do you think about the potential for reaching price parity with SAF, which has some traction with hydrogen as a component, and with actual the Jet A?
We would be at price parity with Jet A at a hydrogen price of $6 to $8 a kilogram. We have already seen term sheets for hydrogen in 2027 for between $4.50 and $7 a kilogram. So we're already there. We've seen a term sheet for liquid hydrogen for $6.80 a kilogram. So we're not just going to be competitive with SAF. We're already competitive with Jet A.
Thank you. A question for Sarah. Let's see here. How do you see aviation collaborating with other hard-to-abate sectors, and what obstacles in California, if we had a magic wand, what obstacles in California would you want to see overcome?
So I mentioned the Infinium SAF that is expected to come online in 2027. Transparently, when Americans signed that agreement, the plan was to bring that SAF to California as a leader in SAF for many years. And due to some of the changes in the regulation, we now no longer plan to do that and are looking for new locations that are more economical for the logistics to bring that SAF. So that would be a really easy thing. And then I think the other thing I would emphasize is And part of all of that context I gave is that I think airlines are kind of screaming from the rooftops, we can't do this alone. And the whole aviation value chain, we have the lowest margins, and we are bearing the brunt of trying to put in the costs to decarbonize. Airlines have announced many, funds for SAF, investing in companies like Zero Avia, and we just need more policy support, more value chain support. And so that could look like many, many different things.
Can I ask a follow-on question there? Because might there be an opportunity in California, because some refineries are choosing to leave, perhaps they could be repurposed with some investment and some policy support in California. Are you thinking of those things?
Yes, absolutely. So not in California, but Valero actually recently did this for a facility that they were planning on. Actually, you know what? I'm going to correct myself. I believe that Phillips 66 just did that in the state of California, repurposed a refinery to focus on SAF.
Wow, beautiful.
And Sarah, what impact does incentives like low carbon fuel standard, how do you see that varying from state to state? And does that affect your purchasing decision? Should California consider that if they want to be supplying SAF or hydrogen?
Yeah, absolutely. Airlines are going to bring SAF wherever it's the most economical to do so. Period.
Thank you. We talked a little about the importance of quantity in airports as a hub. I wonder, Crystal, if you could share, LAX is kind of a unique situation in being a hub. You've got other city departments like Hyperion for sanitation, LADWP with Scattergood nearby. What do you see of that potential with that network as the airport being a point of aggregation as a hub or part of a point of aggregation? What's your insight there?
Yeah, if you guys saw yesterday, DWP was speaking about their geographic location and how they were going to distribute hydrogen everywhere. I am conveniently located right next door. I'm like half a mile as the Cessna flies. So unfortunately, I joined LAWA right after we built this 100% recycled water line directly from Hyperion to LAX. Hyperion is adjacent to Scattergood, which is basically across the street from Imperial Way, and we're just on the other side. Now I'm just going to reopen the street and try and build something new. But ideally, we can make this partnership. I also very conveniently used to work for Public Works. I was the deputy city engineer there, and I worked at Hyperion for a number of years, and I know where their pipelines are buried. I have some already identified. I'm just trying to make that partnership. So that's part of what the dream is. Really connecting Scattergood to LAWA. So I do think that there is a path forward, and it's not that difficult. It's very feasible. But there's, like Sarah was saying, that I'm going to add another layer of complication. There is Lax Fuel, which is a consortium, and they control all of the fuel types according to the airline operations. We have no say in what fuel they bring in. We're just kind of annoying in the background, poking around saying, hey, be sustainable, thanks. But, they have their own drivers and their own business model and then their own customers, and we provide the infrastructure. So my biggest challenge is going to align the infrastructure with our sustainability action plan and our decarb efforts and our need for being prepared for the future and making these connections, at least as I can see across city agencies. So that's the ultimate dream, really.
Thank you. Thank you. A question for Todd and maybe for Jack as well. Yeah, I think we see the earliest generation aircraft being regional propeller driven. What do you see after propellers, and can we compete with routes that are served by jet aircraft?
Yeah, so we have our launch powertrain is for 9-seat propeller planes. Then we're going to 80-seat turboprop planes like an ATR 72 or a Dash 8. That same powertrain can be used to power a turbofan on a regional jet. So that, maybe conservative and say 2032 on that. And then after that, when we start looking at, full size 737s, I think they can be modified. So we have a retrofit model, right, where we're using existing airframes because, as Sarah said, these airframes exist for 30 years. The engines don't last 30 years, right? So you can swap our powertrain onto an existing airframe without having to buy a whole new asset. And when the engines come in for heavy maintenance, they're essentially rebuilding the entire engine, right? So it's not, the CapEx is not that significant at that moment. That said, blended wing bodies and purpose designed aircraft are going to be the way to really get us. We can the last slide, which I didn't really talk about, shows that we can decarbonize maybe 40% of flights with our first 2 or 3 powertrains. But if you're trying to get to transatlantic, transoceanic flight, transpacific, you really need a purpose-built aircraft.
So I understand this turbofan is replacing a jet engine. Its spinning is not driven by combustion, it's driven by electric drive, but it still creates the propulsion that a jet engine would make.
Yeah, that's correct.
Jack, do you want to add anything? And I did see you having the other type of aircraft in the future as well.
I just had one
Oh,
comment.
yeah, please.
about Going hydrogen versus electrification. Those planes with electric heavy batteries are heavy. We are not currently designing our airfields, both pavement strength and geometry, for a heavier plane of that magnitude. We're currently redoing our entire pavement program today, and FAA has not come out with regulatory requirements to develop that criteria for those heavier planes. So I don't know that we can really sustain that in the next 10, 15, 20 years if it goes full electric. So I think that just emphasizes the importance of looking at alternatives.
Yeah, batteries are just, the enemy of air travel is weight, and batteries have nothing but weight.
And let me just mention one additional item, because we've looked at many of these same issues, but one that NASA has invested in are these cryo-cooled electric motors, which have an ability to actually reduce the weight very substantially. They're pretty futuristic still, of course, but if you think about having liquid hydrogen on board, you could use the cooling that it could provide by its own evaporation, which you need for its conversion, to actually cryo-cool these lighter weight motors. So.
Can I just add too, I think that as everyone's talking, to me, something that is raising up or bubbling up is just the importance of us staying in tune with what's happening both in other sectors, but also within our sector as part of these energy transitions, and why I think ARCHES is so important for us, especially the aviation working group. We had this wonderful opportunity to bring together OEMs, airlines, airports, universities to really pull the best in data and science and thinking. But what I'm mapping out in the conversations right now is that these are all transitions that have happened before, from prop to the jet engine, from SAF or from Jet A to SAF. From what we're thinking about from SAF or drop-in fuel to electric. And so we definitely need to make sure that we're leveraging the knowledge and the science, and ideally building upon the incentives and the regulatory platforms that have been put in place as we're thinking about hydrogen. And I say that because, when Todd's talking about smaller aircraft, we're having the exact same conversation about electric aircraft and the eVTOLs of the world. SFO is not preparing for eVTOLs because we have a need to serve commercial aviation, and serving an aircraft that can fly 2 or 4 people does not meet that mandate. And so we want to work with our regional partners, our GA airports, and business aviation to make our airport ready for those types of aircrafts. And there's a lot that you can learn from the electric transition for hydrogen. Maybe we're really trying to start up hydrogen aviation with business aviation and GAs. And I think we need to just think about what those transitions and those stepping stones are, and not lose sight of the fact, and not support one another across the other energy modes that we're trying to launch, that are here and ready as we're getting ready and prepared for hydrogen.
Let me do a follow-up question that for Crystal and for Aaron. As you're listening to your community stakeholders, are you getting feedback either in favor of the pollution reduction, or maybe concerns about safety of hydrogen, that sort of thing. So what are you hearing on both sides from your stakeholders? Crystal first and then Aaron.
I think to Sarah's point and kind of just pulling it in, I think everyone thinks it's so far in the future that they're not talking about it. And I think that's part of us gathering here today and really kind of understanding how the atmosphere is, especially from a constituency. If I'm telling them it's less noisy, I also oversee the noise program and operate a hotline where everyone can complain. So I really do understand like what's out there and what the temperature read is. And it's on the hydrogen front pretty quiet. But if I can tell people that this is a stakeholder benefit to the community and constituents, then that's just another selling point that we need to start engaging.
I guess I would just add that, which is me, I'm like the plus one up here, is that number one, there's a really great white paper that's out there that we did with IATA and the Airport Council International, that is basically mapping all of the risks that are involved with the launch of hydrogen in aviation, prepared by Dr. Alejandro Bloch. So if you want to look that up, SFO contributed, a bunch of European airlines contributed, or airports, excuse me, and airlines contributed. So it does a great kind of sandbox of the types of questions we need to resolve and answer before we're ready to receive a hydrogen aircraft at our airport. And I would maybe echo what Crystal just noted. I don't feel like we're hearing necessarily a lot from our constituents or from our stakeholders surrounding us about hydrogen specifically. What we are hearing is from our airport workers that are out on our airfield. We have 8,000 of them at SFO, and they really want to make sure we're improving our ambient air quality. SFO is in partial non-attainment for ozone. We are hyper aware of SOx and NOx impacts and particulate matter. We have a robust set of sensors that we're building into all of our new terminals. It's an airport standard where we're really monitoring what we're intaking through our HVAC system to make sure that we're safeguarding the 58 million passengers that work inside, passengers that work inside, but the 8,000 airport workers that are outside that are directly adjacent to the combustion of the aircraft we're landing every single minute. And so we are definitely hearing from them more than anyone else that improved air quality is a great net win, and it is something that we need to be paying a lot more attention to.
And interesting, that's similar to what we're hearing from the maritime ports as well. Worker impact and worker fatigue. Those that are driving a top pick, which is a sort of like a forklift that lifts containers, at the end of their shift, they're less tired, not having diesel fumes and diesel vibration. So that worker aspect is a really important one. Yeah. Since we have just a little bit of time left, but since we're in Sacramento, I maybe want to ask a question about what regulatory change on your wish list would you have? Let's go through all the panelists and then we'll do a final wrap-up question. Whoever wants to go first, I'll give you time to think about what regulatory change would you ask for since we're in Sacramento?
I can do something general. So we all fly and we like to complain about flying and the flying experience. And we like to complain about the airlines and we like to complain about the airports. But I will say that the operator margins, the airline operating margins are so slim. And the airports are so resource strapped. And they've got, like Aaron mentioned, you've got eVTOLs coming in, you've got SAF to manage. Now we're throwing hydrogen at them. So anything that can be done to support airports within the state, because the federal government is not going to support them. The federal government has recently allowed airport improvement grants to go to hydrogen infrastructure. Airports have spent their AIP money for the next 10 years. So it's a big issue. And then anything that can be done to de-risk adoption by the airlines would be significant, right? We have, from Zero Hour's perspective, would we love CapEx and R&D money? Sure. We don't need that as much as we need to make sure that airports have the infrastructure and airlines have the appetite to adopt this technology.
So obviously, our business model relies heavily on our passenger employment and the number of passengers we can pull through. I think there was a psychological study done that if one airline posted the same flight $1 less, the majority of people would buy that flight. So even a relief, I know we have a lot of incentive type things, but it also challenges the airlines to stay extremely competitive. And if they do not, they're not winning and they're not getting customers. Um, in that regard, though, if you don't create a policy that's a little bit more direct rather than incentivized, I don't think that, everyone's at such a low profit margin, like both Sarah and Todd said, there's not really going to be an incentive to do anything about it. They're just going to wait until they have to, based on those margins of profit. So I think it's really critical to have a little bit more of an aggressive policy.
Pass the Rubio bill that we have moving through the legislature to expedite and basically give SAF a pathway to fast track through CEQA. That has been a huge holdup, and the majority of SAF producers that are even located, they were founded in Berkeley and Oakland and San Francisco. They're choosing to put their plants outside of California because this is not an environment for development. So approve that and figure out how to get hydrogen on board too, to expedite production there. And then I would also just say in November of last year, Airlines for America signed an MOU with California Resources Board to lift up a working group on SAF. That came 2 years after the CARB, unfortunately not CARB, our governor vetoed a bill that was trying to do the same thing to create a much better environment for sustainable aviation fuel. And now we're that far away from actually launching that working group. So get that working group launched and make sure that there's a member of Arches on it so that we can learn as we're trying to make SAF much more compelling and much more a focus of economic development and prosperity and local energy. Make sure that we're learning from that and doing the same for hydrogen as that goes live too.
Can I say everything they said? I think something that I come back to and something that I always come back to is don't let perfection impede progress, which I think we're all very familiar with. So I think in terms of designing policies, design for progress. I think, we're talking about there's a lot of really ambitious initiatives out there. There's things out there, and just to call out, there's something called the First Movers Coalition that requires SAF that has to be an 85% reduction. That SAF doesn't exist today. So how can we build policy that, allows this industry to get off its feet and then have like clear criteria and timelines to get these producers to continue to innovate, but not, I think a speaker yesterday said, to keep shooting ourselves in the feet. So.
I agree with all of you. Let me add just one detail though, and that is that I think both a carrot and stick are required. In other words, we have to have a regulatory framework in which we are actually over time increasingly decreasing the emissions, increasingly adding SAF, increasingly adding carbon neutral technologies, and then at the same time providing the incentives so that it doesn't cost more. Okay, you put those together, I think that's how you make it happen.
Okay, we have time for one final question, similar to the last one. Let's take 30 seconds apiece. If you could make one recommendation with no regrets to move hydrogen aviation forward, what would it be? And to give you time, whoever wants to go in whatever order, just jump in. 30 seconds. What one no regret recommendation would you have?
Didn't we just do that? That was policy recommendations, I guess. Is there, what are you asking here?
Develop clear standards on how to make infrastructure more agile to receive the fuel and to receive hydrogen in the future for airports that are undertaking master planning processes today to get prepared for tomorrow.
I'd like to remove all political barriers in LA.
That's cool. That's cool.
Some there's a program in California, the SVIP, for fleet renewal for trucks. Something similar. Obviously, I'm not asking that the state buy new powertrains for aircraft because that's going to be expensive, but some sort of measure that incentivizes adoption from the airlines.
Also some funding for my students.
This might be a cop out, but I think it's no regrets to do whatever is possible to continue to build an abundant, reliable, affordable green electric grid.
All right, thank you for that. Let me say thank you to all the panelists for your thoughtful contributions, the lively dialogue. This was really, really valuable and educational. I hope our attendees benefited from much as I did, but I really appreciate the thought and the earnestness that went into the discussion. Thank you very much.
Thanks so much, Mike and Aviation panel.